Oh, I'm having such a good time jumping up and down. It's so wonderful. Jumping up and down in the snow every day. Just pure joy I'm having as I jump up and down.
Oh hey, what you doing? That's really cool. You wanna know something cooler? Is when you jump up and down, you're using your legs to apply an upwards force on the ground and on your body. So you're pushing down on the ground, which pushes your body upward, up in the air when you jump. That's because you're applying a force. That's what that jumping is. It's a force is a vector, which means it has a speed and rather a magnitude and a direction. So, when you apply a force that makes you jump, you're going up, which is your direction, and your magnitude is how high you jump. So if I jump very low, I've got a low magnitude. But if I jump really high, I got a high magnitude. Does that make sense to you, Renaissance man?
Oh yes, that actually makes a lot of sense, and I understand that because I'm in a Renaissance coat, and there's I'm a learned fellow of the sciences like Galileo, and but if you're so smart, can you explain to me why then sometimes you can have you can be walking, but you don't slip and fall over all over the place, except maybe if you're walking on ice.
Oh well, that's actually pretty simple. There's this concept called friction. So whenever two surfaces rub against each other, there's a force that resists that motion, and that's called friction. And it's always directly opposite the direction of the motion that is desired. So, for example, as I walk this way, there's friction on the ground on my feet, and as I walk around this tiny planet and come back to where we were, the friction allows me to actually drag my body forwards as opposed to just running in place, like if I was just kind of moving my feet around in one place and not moving, which is what would happen if there was no friction. So this is why I'm kind of glad there's friction. Friction is, there's different kinds of friction too. So like friction when you're moving is a lot less than friction when you're standing still and you're trying to get moving. That's called the difference between kinetic friction, which is friction when you're moving, and static friction, which is friction when you're not moving. And it's related to your normal force and your mass, but that's all very math related. I ain't got the literature on hand to describe that to you in numerical detail, especially since this film is designed for children who really wouldn't grasp or appreciate the full concept and the application and the literal formulas for these mathematical and physical ideas.
Well, that is very interesting. I really appreciate you helping me out. I really didn't expect a cowboy to be so well learned about these things, especially since I'm a Renaissance man from the Renaissance with a huge head and a British accent from the Renaissance happened in Italy. It's time that this video ended.